Hello everyone. In this lecture, I'm going to elaborate one important theorem, that is duality theorem. So what is this theorem and how it is important? In this lecture we are going to see. So as it is described in the books, like every Boolean expression remains valid after interchanging the operator and identity elements. So we have in Boolean algebra, generally we have two basic fundamental operations. We have two operations like OR, just a moment. So we have OR operation and we have AND operation, right? And identity elements, let's say if one is there, the identity element for one is 0, and for 0 the identity element will be 1, right? So in any of the given Boolean expression, if we interchange the operators as well as the identity element, the Boolean expression or equation will remain valid. So let's see it quickly. Let's say I'm taking few of the examples which we have already seen earlier. So let's say I take the identity. If I write x is a Boolean variable plus, let's say, 0. So we know that x or 0 will give us x only. Now if this is the Boolean expression, if I apply the dual theorem and I write the dual of this particular expression, how we can write? So x is a Boolean variable, so it will remain x. Instead of or, we will use and the identity element of 0 is 1 is equal to x. So this is the dual form of this given Boolean expression, and it is also valid. X dot 1 is equal to x, right? Let's see another. If I write another, let's say x or x bar, it always gives us 1, right? That I have already explained in the previous class. So if you find out the dual form of this by applying duality theorem, we will write x, instead of or we put AND operator. X bar will remain x bar only, but the identity element for 1 is 0. So this is also valid. X and x bar will give you 0 only, right? Now let's see if we take any further example, like x plus x will give us always x. Now if we write the dual form for this, we write x and operator x will also give us x, because x is the, you can say, Boolean variable, and that is the identity for itself, right? Now let's say we consider a Boolean variable x or 1 will always give us 1 only. So if I ask you what is the dual form for this, you convert this. So x will remain x, or operation will convert into and this 1 will have the identity as 0, and this 1 is having identity element as 0. So x dot 0 will give you 0 only, right? Now let's say we have commutative property. So x or y, we can write like y or x. So if we want to write the dual form for this particular expression, we write x dot y is equal to y dot x, and it is also valid, right? Now if we have, let's say associative kind of property. So x or y plus z is equal to x or y plus z. So if we write the dual form for this, it will be written as x dot y dot z equals to x dot y dot z, and it is also valid, right? Let's say if we take the distributive kind of property, so if I write x dot y or z, we can write it x dot y or x dot z or z, right? So if we write the dual form for this expression, we write x or y dot z is equal to x or y dot x or z, and this is also valid because this can be distributed over this, so this is also valid, right? Similarly, if we have, let's say, De Morgan's law, so De Morgan says that x or y complement will give us x bar dot y bar. So what will be the dual form for this? It will be, you tell me what will be the dual form for this? So it is like x will be same, instead of or it will be dot, y is same, and the bar will also be same, right? And it will be equivalent to x bar, and instead of this dot there will be or, and this is also valid, right? So in case if I ask any question in any further class or in your continuous assessment on the duality theorem, you must be able to do it. Okay, so that's all for the lecture. See you in the next lecture. Thank you.